So there's one thing that's worth pointing out, which differs in ggplot than it does from, say, the base plots, is that if you have a plot where the kind of the data kind of exceed the limits of the plot, the behavior between base plot and ggplot can change a little bit. So here on the left-hand side, I've just simulated some data. So this is not max data. And I've intentionally introduced a little outlier here. So in the 50th data point, I've just changed that value to be 100. So now there's kind of this random series of noisy data, and then right in the middle there's a point that's 100. And so if I call plot, so I'm going to make a standard base plot here. I call plot on x and y, and I say type equals L because I want to make a line plot. But then typically, if you have some outlier like this, maybe you don't want to look at the outlier. You just want to look at the core of the data. So it's typical to kind of set the y-axis limits to be roughly kind of where the data are, and then just ignore the outlier. So you can see that the time series that gets drawn has all the data connected, and then you can see roughly where it's going to shoot off to 100, and then it comes back down to be roughly where it's supposed to be. So you know that outlier is out there somewhere, but you don't see it in the plot. Now, if I do the equivalent plot in ggplot, I can create my ggplot with the test data and the aesthetics to be x and y, and then I add the geom line function to make a line plot as opposed to a scatter plot. You can see that it just plots all the data, including the outliers, and it's maybe not exactly the kind of plot you want to make because the outlier is maybe not that interesting. So if you want to do this, you have to be careful about how you do it. And so the first is that on the left-hand side, you might think, well, I'll just change the y limits to be within kind of in the range of most of the data between -3 and 3. The issue here is that what ggplot will do is it will subset the data to include the values that are between -3 and 3. And so of course the outlier is not included in this data set, and so you won't see that data point in this plot. So you can see this clearly where the outlier is missing, the lines are not connected, but then everything else is connected afterwards. So if you want to recreate the kind of phenomenon that you saw with the base plot, you have to add this special function called coord_Cartesian, which that sets the limits to be -3, the y-axis limits to be -3 and 3. And you can see in the plot here that the outlier is in fact included in the data set. The data set hasn't been subsetted to only include the ones that are in the y-axis range. So I just want to go over a slightly more complex example of kind of adding pieces to a plot, just so you can get a sense of how the different layers are added on, and then hopefully get you going from there. So here I've made the scientific question just a little bit more complex. I want to know, how does the relationship between PM2.5 and nocturnal symptoms vary by both BMI and nitrogen dioxide, or NO2. And so as NO2 or BMI values change, what does the relationship between PM2.5 and nocturnal symptoms look like? So one tricky thing about this is that unlike our previous BMI variable, which is categorized into kind of normal and overweight, the NO2 variable is continuous, or it's really the log of the NO2, and it's a continuous variable. So we can't really condition on a continuous variable when we're making plots, because then there would be an infinite number of plots. And so we need to categorize this variable into a reasonable series of ranges. And so what we're going to do is we can use the cut function for this purpose to literally cut the data into a series of ranges. So here's some code to make NO2, to split NO2 into tertiles. So this is going to be 3 separate categories, kind of between the minimum and the 33rd percentile, the 33rd to the 66th, then the 66th to the maximum. And so the first thing I need to do is to use the quantile function to figure out where in the data ranges are the 33rd and the 66th percentiles. Then once I've used the quantile function to find these cut points, I pass that to the cut function, and I use the cut function to actually cut NO2 into these 3 different ranges. And so what the cut function does is just returns a factor variable where each of the original data points is replaced by its category in terms of which tertile it's in, so in terms of the low, the middle, or the high tertile. So it's a very handy function for when you're using things like lattice or ggplot and you have to categorize continuous variables. So now you can see the levels of this variable, the cut variable, there's 3 different levels, just kind of 0.378 to 1.2, 1.2 to 1.42, and then 1.42 to 2.55. So those are the 3 categories that I've split the NO2 variable into. So here's the final plot. I'll just show you what I'm going for, and then we'll work backwards to figure out exactly how to do it. So you can see that there's 8 different plots here. On the top, you see all the normal weight children, and on the bottom, you see all the overweight children. So those are the 2 categories of BMI. And then there's actually four categories of NO2. There's the kind of the first tertile on the left side, the second tertile in the second column, the third tertile in the third column, and then there's actually some data that are missing. And so these are the data that are missing NO2 values, but they're not missing all other values, so you can still in some sense plot them. And so it's often important to look at the missing data just to see if there's anything special about those missing. You don't always just want to exclude them right off the bat, because there may be something special about them that you've missed. So what does this plot have? Well, first of all, I've modified the transparency on the points, so I've made them a little bit transparent so you can see a little bit of the density there. I've added a smoother to each panel, so this is a linear regression smoother, so it's not the default, and I've turned off the confidence bands. There are multiple panels, so I've used faceting to create this plot. I've changed the kind of default labels and the titles, so I've added to reflect, kind of be a little bit more descriptive. And then finally, I used a non-default font. So the default font is Helvetica, and I've changed the font here to be Avenir. And so there are a number of options that I've modified here. And so here's the code for doing it. So in the first set of code, I just call ggplot, and I give it the data, and I give it some basic aesthetics in terms of the x and y variables. And then to this g object, I add a bunch of things. I add points using geom_point. I make the panel using the facet wrap function. And then I add a smoother using the geom_smooth, where I specify the LM method, and I turn off the standard error bars. I changed the theme to be this black and white theme, and then I modified the font to be Avenir instead of the default. And I've also made the font a little bit smaller to be 10 points instead of the default 12. And then finally, I've called the labs function 3 different times to change the labels: the X label, the Y label, and the title of the plot. So you can see that I've added all these different things piece by piece to make this plot a little bit more and more interesting every single time. And it's easy to do this with ggplot. And the nice thing about ggplot, which I didn't do here, is that you could in fact save this to a new object, and then you would have everything stored in a single R object. And then if you wanted to add in more layers, you could add to that new object. You could continue to add different things if you wanted to. So it's a very modular, very kind of useful framework for constructing plots that are new just for your data. So just to summarize very quickly, I know this has been a very brief introduction to ggplot, and there's a lot of things that you could talk about, but given that this is not a course specifically on ggplot, I thought my hope was to kind of get you started, to get you typing in some basic code, making some basic plots, and then if you want to know more, you can kind of look at some of the references that I mentioned previously. So I think in summary, ggplot is very powerful, it's very flexible if you can learn the grammar and learn the different pieces that you can add to a plot. And that can be tuned and modified. There are a lot of different types of plots you can make. I've left out a lot, but you can explore and mess around. I think that's kind of the best way to learn about these things, and to take a look at some of the references that I mentioned in part 1.